Hello, everyone. Welcome to this session on reference architectures for Amazon Redshift data warehouses. I'm happy to be your host here today. Let me start off by giving a quick intro of myself. My name is Asher Mustafa. I am an analytics specialist solutions architect based out of Dallas, Texas. I've been with AWS for about 3.5 years, and prior to that was in industry for about 20 years or so. And I have a background in software development and data analytics. The topics that I'd like to cover here today are to talk about data sharing. What is it? What are some of the common challenges? What are some of the common goals and some of the common business use cases? So I'd like to first start off with a level set conversation about data sharing. And then I'd like to talk about how Amazon Redshift is designed to help with data sharing and how some of its features really can champion and enable advanced data sharing capabilities. I'll also move into some reference architectures that are far from an exhaustive list, but some of the more common and popular data sharing reference architectures. With that said, why don't we get started? Let's talk about data sharing. So what's the idea with data sharing? Well, at its core, data sharing aims to securely and efficiently make data available in one data store, accessible and queryable by other data stores or user communities. And how data sharing is implemented can impact whether data sharing is a cost saver with simple data access patterns and low administrative overhead, or whether data sharing offers complex access patterns that have steep learning curves and long lead times and functions more like a cost magnifier from things such as duplication of data, higher storage costs, and complex access patterns, all of that contributing to extra cost. So, what are some of the common uses for data sharing, common business use cases? Well, at Amazon, one of the things we like to do quite often, always actually, is work backwards from the customer. And when it came to data sharing was no different. Now, this is by no means an exhaustive list of business use cases that we've come across in speaking with our customers, but it's just some of the more popular asks that we've seen. And starting with the first one, the ability to incorporate live data, live operational data into analytics queries, analytics workloads. Take, for example, an event coordinator that would like to incorporate live ticket sales into their analytical forecasts and dashboards. Customers have also told us they would like an easier way to join and mash up diverse data sets in the process of training their ever-evolving machine learning models. And also, many customers have just simply told us they would like leaner and more efficient administrative footprints, lower administrative overhead, and more efficient ways to share their data as a service, to share their data with outside parties. So, what is the common starting scenario for a customer? Well, there are some usual suspects, some anti-patterns that we've seen across many different customers. Things such as a web-like pattern of data pipelines or web-like network of data pipelines and high data duplication. We've seen complex and cumbersome siloed data repositories that deal with proprietary formats and closed systems. Also, we've seen a complex and tedious data governance paradigm involved in the ecosystems. So, how do these usual suspects sort of manifest themselves? Let's give an example to explore that a little bit more. So, take, for example, let's say Example Corp's sales research department needs a few particular data sets for a new project. But there seem to be multiple flavors of those data sets persisted in different areas of the firm. So it must first research the data governance available on all of these different flavors of the data sets that they need So that's task number one, is to just simply figure out what these different flavors of data sets are all about, whether they offer what they're looking for, what discrepancies or differences exist between them, and which provider is the right provider for the data sets that they need. Then it must work with the provider or providers to establish a feed that, to be a subscriber to their feed, or to possibly request a new feed from that provider. And they must bake in the timeline associated with that into their project and any associated costs as well. And then before the data feeds can be used, there must be, there's most likely going to be some transformations needed. So maybe to convert from a proprietary format to an open file format or another format that they need. Not to mention that there has to be proper data quality checks and operational monitoring all put into place. And again, this all has to be baked into the project timeline and the project costs. And in many cases, this all ends up just being a compromise of what they would have really liked, which is more of a real-time capture of the data rather than a point-in-time capture of the data. So in the end, you also have data duplication that is resulting in or causing increased administrative overhead and increased project costs ongoing, not just initial, and increased storage costs. So what are some of the common architecture goals for data sharing? What are some of the common facets of ideal data sharing solutions? Well, in speaking with many of our customers have told us they would like to have to achieve workload isolation. They would the ability for a workload running on one system not to impact the compute capacity of another system. They would also like to achieve a straightforward chargeback model where they are able to, with a fair amount of ease, be able to identify, okay, customer A is running on Redshift cluster A and customer B is running on Redshift cluster B. Therefore, at the end of the month, we can easily ascertain how much of a cost footprint is due from customer A and how much is due from customer B, and so on. And then also our customers have asked us for an easier way to refresh development test environments with quality production data to simplify that whole task. In addition, as I mentioned, leaner and more cohesive data governance has often been a common ask, and minimizing data redundancy, which would lead to improved performance, reduced time to market, as well as reduced costs. So let's now shift gears a little bit, and let's take a look at how's data sharing in Amazon Redshift achieved. I'd like to start off the discussion by first talking about data lake architectures. Let's first talk about what is a data lake for level set, okay? So a data lake is a centralized repository of all of an organization's data. So all of the data in an organization, all your structured data, your unstructured data, your refined data, your raw data, all of your historical data, your warm data. Ideally, it is all of your data, your operational data, your business data, and so on. All of it captured in a centralized repository. And one of the most common implementations of a data lake is an S3 data lake. Now, many customers are increasingly adopting a data lake architecture to help them unlock value from their data and to handle the increasing volume and variety of data in their modern data ecosystem. But the benefits of a data lake architecture does not stop there. It also really lends itself to providing advanced data sharing capabilities. For example, Amazon Redshift provides a seamless integration experience with your data lake, so much so that Redshift is the only solution that offers 1 foot in the data warehouse and 1 foot in a data lake. With this pattern of having 1 foot in the data warehouse and 1 foot in the data lake, we affectionately call it a lake house pattern. So a lake house in the sense that Amazon Redshift sits on top of your data lake and it extends to your data lake. So in Amazon Redshift, when we say it seamlessly integrates into your data lake, what we mean is it allows you to query the data sitting in your Amazon S3 data lake without moving or transforming that data. You query it in place, and we'll see more about that. We'll talk about more of that in just a moment. And with regards to the data lake as well, in terms of data governance, by using lake formation, you can establish the data lake quickly, but also benefit from security, access control, and more that's built into lake formation, an AWS service, another AWS service. So Amazon Redshift, we've mentioned, seamlessly integrates with your data lake. And the data lake architecture helps provide a more advanced data sharing capabilities. So let's first talk about the feature of Amazon Redshift that allows you to query your data lake. Amazon Redshift Spectrum is that feature. It allows you to query open file formats in your data lake, such as Avro, CSV, Parquet, JSON, and many others, directly where it sits on your S3 data lake. So it's not like the data has to be picked up, loaded into Amazon Redshift, and then queried. No, it's queried in place. And one of the real benefits of Amazon Redshift Spectrum is that it is powered by an independent fleet of Spectrum servers. So the compute capacity doesn't for executing those queries is not necessarily coming from your Redshift cluster, but from an independent independent fleet of very powerful Spectrum servers. And those Spectrum servers execute the query on the data where it sits in your S3 data lake, and then return the results to your Redshift cluster to continue processing for the query. And with Redshift Spectrum, you can query exabytes of data where it sits. So you have the ability to establish the the best practice of keeping your quote-unquote warm data in your Amazon Redshift cluster and your cold or infrequently accessed data, or your historical data, out in your data lake, where it is only incurring low storage costs, but still being accessible and queryable by your Amazon Redshift cluster as if it were any other table using standard SQL. And with Amazon Redshift Spectrum, it unlocks the data sharing access patterns that I had previously mentioned, which is now that we have the data lake, with ideally it being a centralized repository of all of an organization's data, there now is the ability for multiple Redshift clusters to access common data sets from the data lake directly. So with Amazon Redshift Spectrum, maybe certain reference data that is infrequently accessed but still needs to be accessible for analytical workloads can be now, not instead of it being loaded, it can be shared among loaded into multiple Redshift clusters, resulting in high data duplication. Now it can be persisted in your S3 data lake and accessed and queried in place. So resulting in a high degree of data sharing for that particular use case. In addition, many of our customers have told us they would really appreciate an ability to avoid having to build out the traditional pipeline of extracting data from their RDS instance, their relational data stores, and then loading it into their data warehouse so that they can incorporate certain operational data as close to live operational data as they can get into their analytical workloads. Now, again, I say as close as they can get to live because it isn't really live. When you do an extract, it becomes a point-in-time snapshot of that data. Well, with Amazon Redshift Federated Query, you can do just that. You have the ability to query data that is sitting in your Aurora RDS Postgres or Aurora RDS MySQL instances, where they sit, instead of having to extract the data and then load it into Amazon Redshift. And you are now able to incorporate live operational data into your analytical workloads. So that example that I offered earlier on where an event coordinator was interested in incorporating live ticket sales into their analytical forecasts and workloads and their dashboards. That's exactly what Amazon Redshift Federated Query will help a customer achieve. And Amazon Redshift also has a full-fledged data sharing capability among Redshift clusters. So it is possible for data in one Redshift cluster to be queried by another Redshift cluster. And this results in many possibilities, many access patterns, two of which are shown on this slide, and we'll talk a little bit more about later. But just in brief, Amazon Redshift data sharing allows a Redshift cluster to establish a schema that is linked to data that is a reference to data sitting on another Redshift cluster. And so there is no data movement required or data duplication. The Amazon consumer Redshift cluster is able to query data sitting in a producer Redshift cluster, for example. That's one of the patterns that are shown on this slide on the left-hand side, without having to have a full-fledged copy of the data itself. On the left-hand side here, we have the producer-consumer pattern where you have a set of common data sets housed on the producer cluster, and then you have some satellite consumer clusters, Redshift clusters that are querying those common data sets as needed, but at the same time housing their own isolated data sets. And that leads us to the second pattern that's on the right-hand side, where you have a bunch of Redshift clusters that are housing their own unique data sets. And there may or may not be certain opportunities for sharing of those data sets, certain use cases that benefit. As I mentioned, some of our customers were looking for an easier way to join diverse data sets to help train their ever-evolving machine learning models. And then finally, there's the Amazon Redshift Data API. And this is primarily helps with applications such as Python applications or Java applications that are typically, in many cases, working with REST-based APIs. The Amazon Redshift Data API opens up a REST-based interface to the Amazon Redshift cluster. It allows for data queries to be executed over these REST-based APIs, and catering to these applications and enabling a greater level of data access and data sharing. Now let's shift gears a little bit and talk about reference architectures. First, reference architecture, and again, this is not an exhaustive list of reference architectures, but just some of the more common ones. And this is exactly one of the most common ones that we see. We have operational data stores feeding their data, publishing their data feeds to the data lake, which again, as we mentioned, is a centralized data repository of all your data, your structured data, your unstructured data, raw data, refined data, all your historical data, your warm data, all of your data. And then from there, certain transformations are performed on the data to convert it, from raw data to refined data. And that might be performed by AWS Glue or EMR or Redshift even itself, or other other services. From the ETL, we would load it into Amazon Redshift, a producer cluster. We would acquire the refined data sets, could be certain common or core data sets that may be very large and not ideal to duplicate. So we would load them into a producer cluster where it would then be available securely and efficiently through the Redshift data sharing facility to other consumer clusters. So other consumer clusters would be able to query those core data sets where they sit in the producer cluster without actually having to house a local copy of the data themselves. Another reference architecture is one that I briefly mentioned earlier, where you have a set of isolated Redshift clusters, isolated data sets that have their own upstream data sources that feed into their unique data sets. I mentioned one example before where a customer was interested in joining diverse data sets to help improve and train their ever-evolving machine learning models. Well, this is an example where you have multiple Redshift clusters talking to each other, sharing data without duplicating the data, and doing it in a secure and data-governed way, and efficiently data-governed way, to enable that level of data sharing. And then finally, data as a service of reference architecture, where you have upstream sources essentially feeding data into Amazon Redshift clusters. Transformed data sets are being pumped into Amazon Redshift clusters. And then from there, those Amazon Redshift clusters are making data sets available to both external and internal parties. Again, a data as a service. And this is all, again, possible with the data sharing facility within Amazon Redshift. So I highly encourage you to continue learning on this topic and other analytical topics and other AWS topics. And these are just a few resources that you can use to help on that front. Highly encourage you to also check out the ramp up guide, the link at the bottom there. And with that said, I thank you very much for attending this session, and don't forget to complete the survey.